let's talk a little bit about gaming. First of all, I'm not a game developer, right? So big, huge shout out to all of you, because I am a gamer, and so without y'all, I would not be to play the games that I play. But what I am is a full stack developer since 2004, so I've been doing a lot of web development, front end, back end, SQL, JavaScript, Java, you name it. On the web side of things, I've been working in it for almost 20 years now. But right now, I'm a developer advocate at Twitch. And I live in this kind of weird world between Twitch and AWS, which we'll talk about a little bit more in a little bit. Those are my socials. That is an amazing NFT that somebody created for me. Kind of looks like me, right, without the gray. But so before I get started, I just wanted to kind of show this off, because like I watched this TikTok video that showed me how to do these amazing animations in PowerPoint. So that's like the extent of my design ability, that 40-second TikTok video that I watched. But let's talk about the agenda. So we're going to talk about Amazon Interactive Video Service. And you're probably all sitting there saying, what the heck is Amazon Interactive Video Service? We'll get to that. We're going to do an intro to real-time streaming. We're going to talk about some of this. It's a very new service that we just launched about a month ago, and we're going to talk about some of the terms related to that. We're going to do a web SDK demo really quickly to kind of just illustrate what it is, show you what it's about, and then what you're probably all asking, what the hell does this have to do with me, right? Oh, you know what? I forgot. Is anybody from Kansas City? Yeah? Detroit? Detroit? Y'all must hate football.
Yeah.
Because it's like opening night of the NFL, and the Chiefs and the Lions are playing, and there's like a Chiefs bar right next door. So thank you for coming here instead of watching the game. So what is Amazon Interactive Video Service? It's an AWS service for managed live streaming. And essentially it's built on the same technology that powers Twitch, right? When you think of Twitch, has anybody heard of Twitch? Just a few, you're right. It's basically a service that allows developers to build their own platform. So you can create channels to do live streaming, you can add interactive chat, you could do things like record all of your videos to S3, you can add timed metadata, which is a really cool feature to allow you to embed a piece of data at a specific point in time in your stream and then react to it in the player later on. And as I said, you can add interactive chat. And as I mentioned last slide, brand new real-time streaming. So low latency live streaming, we're talking about 2 to 5 seconds of latency, depending on a lot of factors, right? Your bandwidth, your viewer's bandwidth, the network capabilities, the machine, things like that. Real-time streaming brings that all the way down to 300 milliseconds of latency, so almost nearly imperceptible latency, right? And this is kind of what low latency looks like from a architecture standpoint. My amazing design skills on display again. You have your broadcaster, they ingest the feed via RTMP, and that's delivered via HLS to the viewers. So HLS being based on HTTP, that's where the 2 to 5 seconds of latency happens. Real-time live streams utilize WebRTC, which is how that latency is brought down to around 300 milliseconds. You can also do a flexible configuration, what I call flexible configuration, where similar to the feature Guest Star on Twitch, where that allows you to invite another streamer to join you, kind of co-host the stream, right? The WebRTC can be used to facilitate that real-time communication between broadcasters, but if that real-time latency is not necessary to the end viewers, you could then have that delivered via HLS to the end user. So depending on your use case, there's a lot of options and flexible configurations. We're gonna look at, like I said, a really quick web demo. This is a QR code if you want to check it out for yourself later on, or you could hit that bit.ly link. But we're gonna kind of walk through the process of creating what's called a stage and connecting up to that stage just to kind of illustrate how it's done on the web side of things. So I'm gonna go to that. And if at any time you have any questions, would like to, make any other comments or anything, please feel free to let me know. So this is the AWS Management Console for Amazon IVS, and several options here, but for real-time streaming, we're going to create what's called an Amazon IVS stage. So to do that, we give this stage a name, and I'll call it Dev Meetup, and I'll click Create Stage. At this point, our stage is ready. We can start broadcasting to it. So if I scroll down a little bit, every participant that joins a stage has to have a participant token, and it's just a JWT token that's used to associate their user ID, username, and just validate the connection. So we're going to create a participant token, and we'll call this one Jordan. And Jordan's going to have the ability to publish and subscribe. So I'll click Create Participant Token, and I'll copy that token, and if I come over here to this CodePen demo, I select my camera and my microphone, and I paste that participant token in, and I join the stage. I'm now connected up to that stage, and I'm broadcasting. So if I open this up in a new tab, and I create another participant token, we'll call this one my buddy Hassan, and we copy that and paste that. It's gonna look a little crazy because they're both me, but at this point I've got a conversation between my two tabs, a real-time conversation between two participants connected up to this. And as we close that because I was getting audio playing back through my speakers, and it was getting a little crazy. So what does this mean to you? Well, this means that anything that can produce WebRTC, can connect to WebRTC and produce to a channel, can do live streaming over Amazon IVS. So what I thought would be really cool, as I said, I'm not a game developer, but what I thought would be really cool is to have a demo where I create a Unity application and I create a game that publishes to a real-time channel. So that's what I had one of my engineers do, and he shared that code with me. So I'm gonna run through that right now. So let's quickly look at the steps that it takes. First thing we need to do is create or edit an existing project. We need to get a hold of the Unity WebRTC package, and it's located on GitHub. It's something that they put out to do integrations like this. We need to add that package to our project, add a new camera, and add a script to the camera. And that link right there is the script that we will use. So let's go ahead and do that right now. So I've already created a new project. And as I said, you go to Window Package Manager, and you add that WebRTC dependency. In this case, I'm using version 3.0. I tried adding it from the Git URL, but it gave me issues doing that. I don't know do y'all ever have success with that in Unity, or is that like a known issue? Not sure, okay. So I downloaded it, and I just added it from disk, and everything worked fine. So once I've got that dependency added to my project, I click on Main Camera, and I come over here, and I know that's a little bit hard to see, but I add a camera to my project, and I've already done that. But on the camera, if we go to the inspector, I go to Add Component, and then I added the script. And the script to handle this looks like this. Y'all see that font okay? Is it big enough? Cool. So this script is what handles all of the connection to the Amazon IVS stage. First thing I do is declare a peer connection and a track and a camera. In the start method, I start a coroutine. I declare that, or I create that peer connection. I have a on ice connection state listener, and that I just debug the state. Then I get a camera, get a reference to the camera, and I create a capture stream track. So this is basically a media stream track that represents the camera in the game engine. Then I add that track to the peer connection, and down here, well, I start the coroutine do whip, sorry about that. And then in the do whip function, I create what's called an offer. So with WebRTC, you need to create an offer. Sorry about that. And then set a local description from that offer on the WebRTC connection. Then I create a SDP, which is called a session discovery protocol in WebRTC, and then I log that out. And then finally down here, this is really where the magic happens. So I create a new web request using the whip endpoint from IVS stages, and that ends in a participant ID. So when we created our participant back here in the console, and this is all obviously able to be done programmatically via our SDKs. You're not going to hard code these things into your app like I've done here. But every time you create a participant, you get a participant ID. So that's what the end of that URL is added to the end of that URL. Then we have an upload handler, a download handler, and then we set a couple headers. The first thing we have to set is the content type, which is application SDP, service session discovery protocol. Then we add a bearer token as the authorization header, and that bearer token is the JWT from the participant token. So if you were to actually decode this in as a JWT, you would get all of the information related to the participant, the ID, any metadata that you attach to it. But again, you're not going to hard code this like I've done here. You're going to use our SDKs to generate a token, retrieve it, using a web request to do that as well. Then we send the request, make sure that we don't have any errors, and set the RTC session description based on that result. Once that's all done, if we run the game, at this point, we should be able to connect up to the stage and broadcast our game. So I have a question. I am a gamer, but I use console, so I'm a terrible keyboard gamer. Does anybody want to play a game? I want to play. Whoa! What's your name?
No.
What is it?
No.
Noah. M. Moa.
Noah.
Noam. Noam. Hey, I used to work with a guy named Noam. Yeah, okay. Give a hand for Noam. So, Noam, we're gonna run this game.
Top 500, right?
Hold on.
All right.
Oh, on the pad.
Yeah.
Okay.
So, all right. So what Noam is gonna do is he's gonna play this wonderful game that I've used from the samples directory, and we're gonna go through that door. But what you see on the right here is the game in Unity, and what you see on the left is it real-time streaming on the web. So he's actually streaming this gameplay, and the latency is almost imperceptible.
Just go anywhere?
Yeah, go ahead. Go down the ramp there. Go to your left. Oh.
No. Oh, you have to hold down the mouse pad. I'm so used to a keyboard. Oh, he was up one health. Thank you.
Operation Thought.
So, to me, this is like ridiculously amazing to be able to stream this directly from a game engine with that kind of latency to the web. Let's go back to the slides here and talk about it a little bit more. Oops, we've got way ahead of time here. So why, right? Why would you do this? To me, like, this opens up like ridiculously new levels of interactivity for gaming, right? We started in gaming many, many years ago. I've been gaming since I was 8 years old, right? I got a paper route and I bought my first Nintendo. And at first, gaming was a very individual experience. We sat in our living room or our bedroom or our basement and we played the game by ourselves. As time went on, I'd like to say that I actually invented Twitch, but it was kind of different. I got to a point like 25 years ago where I was living with some buddies and I would sit in the living room and I would watch him play, Zelda Ocarina of Time. And I would sit there and like, no, go over here. No, do that. So it was like, we kind of moved into this era where we consumed video game content instead of just playing it ourselves. We got into this, and then Twitch came along and exploded and became this amazing, huge community of people who have this shared interest in a game and brought so much interactivity, and you'll learn about some of that in a little bit here with Thomas's talk about some of the amazing things that are possible to add that layer of interactivity. But this, to me, opens up possibilities to do so much more. Why would you want to create your own live streaming application is the question, all right? Customizable, multiple dynamic camera views. Imagine like a boss camera where you could actually like watch from the boss point of view, or like an overhead camera, and let the streamer or let the viewers actually watch from a different point of view. Imagine integrating chat to actually like impact the gameplay. So like have your chat burn a poll. How big should the next boss be? Where should the next boss be? How much loot should be dropped? Actually dynamically affecting the gameplay. Opening this up to AR, VR, all these opportunities that can really dynamically affect the environment from within the game engine itself. You don't have to worry about third-party software running that on top of while you're running the game engine, running OBS in the background. You don't have to worry about any of that. Like I said, viewers affect the gameplay. Building that brand loyalty for your game or your own engine or your own company, monetizing the players and viewers by yourselves. And as I said, you tell me, like, what kind of ideas can you imagine can be done with this? I think I'm not inventing this or by any means, but like I think we're just scratching the surface. And we're really kind of at the horizon of a really new era in gaming that's going to open up new levels of interactivity. So there's one more kind of way we can do this. And I've got Jonathan Thomas's permission to show this here. But the other option here is to actually broadcast directly to Twitch from a game engine. So how do you do that? It's nearly the same identical process. The script is a little different. So if you actually want to give your players the ability to broadcast directly to their own Twitch channel, you could do this with almost the same code, but it's just a little bit different. So let's look at that demo. And I'll jump back over to Unity and I'll switch to that project. Probably actually close the PowerPoint so you can see that. So I've got this 2D side scroller project. And again, the same process. I went in, I added a camera, I created a script, and if we look at that script, it's essentially the same thing. The only difference I had to do was add a audio transceiver. I was getting some errors when I ran it without adding this, so I had to add an audio transceiver to that peer connection. But the web request is almost identical, the only difference being a different URL. And if you follow that link that I had on my slides, you'll see a gist that'll show you this URL. And this is the web ingest endpoint for Twitch itself. And then down here as our bearer token, instead of that JWT, that participant token, we can actually use our stream key. And I've got that hidden here so that y'all don't copy it and stream to my Twitch channel. But we just pass that as our bearer token. And if we run this, And we give it a second to catch up. I'm not very active on my own Twitch channel, Jonathan. It's a little bit less, it's not real time at this point because what's happening is we're using the web ingest, but it's still being converted to HLS at this point. But if we start our little game over here, I'm doing pretty good at this game. My wife, I'm gonna calling this, she's gonna say, what do you do? Oh, I played a game in front of 70 people. But you can see on the left there, I'm broadcasting directly to my Twitch channel right from within the engine. So again, no need for third-party software or OBS. Obviously, you're not gonna hard code this directly in your stream key directly into the engine. You could use the APIs, and I'm sure Jonathan would love to tell you all about, and Thomas and Mark. But it's just another option to give your game players the ability to integrate with their Twitch stream directly from within your game engine. No reliance on any third-party engines. So, that all being said, is there any questions?
All right, well, round of applause. Whoa, let's go.